All right, guys, we did it. We made it to the tangent ratio. We are looking at this right triangle here, and I know it is a right triangle from this notation, and I have to know it is a right triangle. I'm going to find out what this x value is using my tangent ratio, and I can only apply this on a right triangle, at least at this point in your math career. So the tangent ratio is going to be the tangent of an angle, so we'll do of theta, right, a random angle number, and it's going to equal a ratio. It's going to be from that angle, it is going to be the opposite side over the adjacent side. We talked about it a lot as a slope ratio. The tangent ratio is the same as the slope ratio. It is the same as the rise over the run, but thinking of it this way kind of really means we got to like reorient our paper, and we got to think of this thing as a slope ratio, right? Kind of turn it this way, look at the 58-degree angle here, and think about it as the rise over the run. And we want to avoid turning our paper anymore. So we're going to use this language now, the opposite over the adjacent, to figure it out. The acute angle that we're going to use here is going to be this 58-degree angle. So this 58-degree angle that's marked here, that's my acute angle that's going to represent my theta. I am then going to look across the triangle, and I'm going to do this 22. That's going to be my opposite side. And then my adjacent is going to be this side right here. It's the side next to 58. Now, if you're wondering how I knew that this side right here was x, that is the adjacent, and not this guy, that's because this is the hypotenuse. And the hypotenuse is going to get used in two other ratios, which we haven't talked about yet, the sine and the cosine. Right now, we only are using the tangent ratio, which is our conversion of the slope ratio, which is going to be the opposite side, so all the way across the triangle, and then your adjacent leg. It's the two legs of the triangle. We will not use the hypotenuse in the tangent ratio. Okay, so now that we know that, and we're clear on what we're doing, we can go ahead and set this up. The acute angle that we have here in this right triangle is the tangent of 58. And that is going to equal 22 over x. Now we need to solve for x. And this tends to look a little bit confusing the first time people see it, right? Because it looks like not only do we have letters, variables in our math now, right, with the x, we also have almost an entire word. But the tangent of 58 is just a number, all right? I can prove that in the calculator. The tangent of 58 is just a decimal. It's about 1.6. Now, it comes from the ratio in any right triangle with a 58-degree angle. They're all going to be similar because of angle-angle similarity. So if I have a right triangle with a 58-degree angle, this side over that side, they're all going to be proportional. They're all going to be similar. So this constant will be a decimal from the calculator, and it's going to equal to this specific one, 22 over x. Okay, so let's solve for x. The problem right now is that x is in the denominator. I got to get it into the main line. I want to have x equals a number, right? So I need to have x out of the denominator. I'm going to multiply both sides of this equation by x. Which feels a little bit weird, but we do that so that x is now in the main line. We have x times the tangent of 58, which again is just a number. So this is really just x times a number. That's going to equal 22. We want to get x by itself, so we need to undo this multiplication. And we undo multiplication with division. So we're going to divide both sides by the tangent of 58. Which again, it looks weird. It looks like it's a word, but it's just a number. 22 divided by the tangent of 58 is going to be our answer, and I'll make the calculator do that. I'll clear that out. 22 divided by the tangent of 58. And it's going to be about 13.7. I'll round that to the nearest tenth. So my x here is going to be about 13.7. So that is this length right here, which seems reasonable for this diagram, even though it's not drawn perfectly to scale. 13.7 is a number that would, I think, make sense if this was a 58-degree angle. That was 22. Hypotenuse would have to be the longest side. This looks like it would be opposite the shorter angle, or the smaller angle here, right? And I know that that is, let's see, 180 minus 90 minus 58. It's 32, right? This is a 32-degree angle here. And we know from our relationships of opposite angles inside, right, the smallest side is opposite the smallest angle. So that fits. 90 biggest side, 58 middle, 22 is in the middle. Okay, that's my final answer. X is equal to 13.7. I use the tangent ratio to get there, the angle, opposite over adjacent, set up the equation, solve for x. Message me anytime with questions.